All right, I'm here with Christof Koch. Thank you very much, sir, for joining me today.
Thank you for having me, Duncan.
So I just got done reading your book, The Feeling of Life Itself, and I thought it was great. It's accessible to a popular audience, and just to lay the groundwork of the discussion we're going to have here about consciousness. That word, consciousness. Can we even, is there an agreed upon definition of what consciousness is?
Given that this is a question that has been asked for more than 2,000 years, at least in Western culture, there's no universal agreement. Most scholars, philosophers, and scientists who study it, most, not everyone, argue that it's ultimately experience. The fact that I see, I hear, I dream, I desire, I love, I hate. I have feelings of pain and of pleasures. And I can imagine a world in which all of those things are true in the sense that my body moves, my body procreates, my body runs and responds to visual stimuli like a robot, but without any feelings. So this feeling part, where does this feeling part come from? That's really the heart of the ancient mind-body problem. Where do the feelings arise? We know that if I look at the foundational equations of physics, if I look at quantum mechanics and general relativity theory, there's nothing there about consciousness. If I study the chemical elements, the 92 elements out of which everything here on the planet is made, there's nothing about consciousness. If I look at inside the genes, the genome, if I look at the ATGC chatter of my genes, there's nothing there about consciousness. Yet every day I wake up, I come from nothing, from nowhere, right? When I'm in deep sleep, suddenly I'm there and I feel, I feel my body moving in bed. And then tonight, again, I'm going to go back to bed, and then at some point, gone. It's just no one there, right? And then, so where does this come from? That's the heart of the ancient mind-body problem. That's what experience is. That's what consciousness is.
This mind-body problem, is that really the best way to frame this question, though? In other words, what you're doing as a physicist and exploring neuroscience, it seems to me, at least, that you're searching for some scientific, maybe materialistic explanation of consciousness, and which is to say that consciousness has a physical origin. So in other words, why make a separation between mind and body?
Well, my brain is closely associated with consciousness, your brain as well. We know this because if somebody hits me on my head, I lose consciousness. If you have injury to your brain due to accident, gunshot, drugs, alcohol, whatever, you lose aspects of your consciousness. So we know there's an intimate relationship between my brain and my mind. My mind just being everything my brain does, conscious or unconscious, my behavior, the fact that I can speak to you, right? That you ask me a question and I can give a meaningful answer. Those are all aspects of my mind. They closely relate to the underlying physical hardware, the brain, but they're different. I can assure you, right now I'm looking at my office here and the books and the bookshelf and the computer, etc. There's nothing directly in my brain that looks anything like it. I explore brains every day. We record from them, human or animal brain. It's gray goo inside. So clearly what I experience when I have pain or pleasure or see or hear is different from the underlying hardware. So I'm trying to be as little prescriptive early on as possible. All I know, there's a brain, there's my mind, both that have both conscious and unconscious aspects, and there's a clear relationship between those, between the mind and the brain. Even to the extent that I know specific bits and pieces of my brain are associated with specific aspects of my mind, like my ability to see, or my ability to see color, or my ability to feel familiar and happy in a particular room or with a particular person. We know those have particular material parts of the brain associated with them. So we know there's this close relationship. But we still need to understand, is that true for all aspects of the mind, and how does this relationship arise? Because it's not apparent, as I said, from the normal sciences, that there should be feeling. My liver, for instance, as far as I can tell, my liver doesn't feel like anything, right? But my heart doesn't feel like anything, although we all use heart-laden imagery. You know, I tell you I love you with all my heart, but it's really the hypothalamus or the prefrontal cortex that's involved when I'm talking about the love for and for somebody else. So certain parts of my body, like the brain, have a preferential association with mind, not other parts of the body. And so again, why is that?
And I guess that's a good leaping off point to talk about integrated information theory. Could you, is this an attempt to sort of explain where that feeling of life itself arises from?
Yes, so science is challenged, as we said, but trying to explain the relationship between mechanistic things like my brain, or for that matter, a computer, or my iPhone chip, and these immaterial, ineffable things, my love, or the feeling of life, or the feeling of seeing blue, or being distraught or upset about something that just happened. And ultimately, so as neuroscientists and neurologists, etc., we will be able to track down what I call the footprints of consciousness in the brain. So in the fullness of time, after all the research is complete, in a century or two, or maybe even longer, we'll know precisely which bits and pieces, under which condition, give rise to a specific conscious aspect of whatever. When you tell me I'm feeling distraught, at some point in time, I should be able to say, well, yeah, I know, because this neural mechanism in your head is active, therefore you're feeling distraught. And furthermore, it's a two-way relationship. When I remove that bits and piece of the brain, let's say through surgery, you won't feel distraught anymore. Or when I artificially activate that bit of brain mechanism using an electrode or a magnetic coil or some fancy matrix-like technology, then you will have this feeling of being distraught. In fact, you can induce it in some patients by electrical stimulation of their cortex. This has been done. That's all good. I still need to understand, though, what is it about rubbing this piece of the brain, with an electrode that gives rise to the genie of consciousness. So I know from, for example, working with neurosurgeons, I'm thinking of a particular study at Stanford where they stimulated during neurosurgery one particular part of the cortex, the temporal cortex, and the patient reported this feeling of dread. And it's reliable. You can stimulate it again and again. The person has this feeling. Well, why should rubbing a particular piece of matter give rise to any feeling, let alone the feeling of dread? So ultimately, besides having this brute correlation, okay, this part of the brain gives rise to that feeling, and that part of the brain gives rise to that feeling, I need to understand why and what is it about the brain that gives rise to it, and is it only brains, or is it also other pieces of matter? I mean, the brain, after all, is a piece of furniture of the universe like any other piece. It has to obey the same law. It follows the same law that everything else in the universe has to follow. There aren't any, at least we believe, there aren't any extra supernatural laws that only brains have subject to, that other things aren't subject to. So we need sort of some rigorous, hopefully quantifiable, rational understanding. What is it about particular mechanisms that give rise to consciousness? And so this integrated information theory, or IIT, is an attempt, I think it's a reasonable, successful attempt, to try to do that, to say precisely what consciousness is, which systems have it, how you can describe it, how you can measure it, and how you can delimit it, which bits and pieces of a mechanism are in and are conscious and which are out, and does it extend into the wider world outside humans, outside animals, outside biology, maybe even into technology? Those are all questions that IIT has precise answers to.
Right. So that's one of the the questions that people have specifically about like eating meat is, you know, a lot of people who go, you know, vegan or vegetarian, people will say, oh, well, you don't want to cause suffering on some conscious creature like, you know, a pig or a cow, but how do you know that a stalk of wheat is not conscious as well? And so I guess what integrated information theory would say is that on some level, a, a, a plant is also conscious on some level. Like it's on, it fits on some spectrum of consciousness. It has some, I guess, like following the theory, it has some non-zero phi score, which I suppose is a measure of consciousness.
Yeah, so as you point out, IIT shares some panpsychist intuition. So panpsyche, the Greek word, you know, from pan, everywhere, psyche, soul, is a very ancient faith, both in the West and in the East, that says consciousness, feelings may be much more widespread than conventionally thought of. So we imagine, okay, we are conscious, and great apes are conscious, gorillas and elephants, and a few sort of, you know, charismatic megafauna. But then if you look at the evidence from a more scientific point of view, you wonder, well, why only those? I mean, for example, we study at the Allen Institute for Brain Science the brains of mice and the brains of humans. And cubic meter per cubic meter, they look very, very similar. In fact, only an expert armed with a microscope can tell the difference between a human brain, a little bit, you know, if I give you a little quinoa piece of human brain or a little similar sized bit of mouse brain, they really look very similar. The neurons are similar, they're not identical, but the neurons are similar, the neurotransmitters are similar, the synapses are similar, which is why we can use the mouse as a so-called model system, because it has these great similarities. So then people say, well, maybe consciousness probably extends across all mammals just by their behavior. You know, if you grew up with a dog or a cat, you have no problem as human. Yeah, they can clearly be fearful, they can be very playful, they can be curious, they can, you know, they can really like, they can sort of be angry. And so the assumption is, well, maybe all mammals, but then again, you limit, well, what is special about mammals, the mammalian brain, that, let's say, the brain of a crow, you know, birds, or of a squid, a cephalopod, you know, which has a very different evolutionary history, doesn't share. What about the bird, the brain of a bee? Bee only has 1 million neuron compared to 86 billion of the human brain, so it's roughly 100,000 times smaller. But the brain of a bee is amazingly more it's per unit volume 10 times more complex than the brain of a human. Bees have very complex behavior. So again, why should we rule out, by what rational reasons do we rule out bees? I'm not saying a bee has a voice in its head and the bee thinks about the weekend, but I'm saying given the great behavioral, neuronal, and evolutionary continuity across these different species of animals, it may well feel like something to be a bee. It may well feel happy when the bee has just drunken some golden nectar and is flying under the warm sun home to its hive. Now, IIT tries to tackle that. It has, as you mentioned, this measure of consciousness, phi. It's a number that's either 0, there's no consciousness there, or a positive number. The bigger the number, the more the system exists for itself, the more it is irreducible, the more it is conscious. And yes, as you point out, given the vast complexity, the untold complexity of even individual single cells that may contain, you know, thousands of different proteins, and, you know, maybe a billion or few billion different proteins of 1,000 or several thousand different types, no one has ever modeled all of this complexity. It may well feel like an itsy bitsy thing to be that single cell, let's say that paramecium. Once again, I'm not saying this paramecium has a psychology or feels fat or worries about the weekend, but all I'm saying, it may feel a little bit like something. And when you destroy the paramecium, when, let's say, you pop its cell walls, it doesn't feel like anything anymore. And that's fundamentally what consciousness is, feeling like a little bit or feeling like a lot. And so therefore the intuition is, yes, consciousness may well extend, you know, into a much larger realm than we conventionally think of.
I think intuitively that makes sense. That obviously we're not alone in terms of feeling something. I mean, you don't want to anthropomorphize animals, but you can tell that they're not just, you know, objects or dolls. There's something going on there.
Correct.
But there is a critique of IIT, integrated information theory for short, by a computer scientist named Scott Aronson.
Hmm.
Have you read what he's written about it, or am I
Yeah, no, it's correct. I talk about it in the book, The Feeling of Life Itself, about his
right?
specific criticism.
Okay,
You want to
um,
talk about that?
please, yes,
Yeah, so Scott likes the theory because he says, well, it's the first really theory of consciousness that he's met that makes precise prediction, that actually there's a calculus associated with it. It's not just hand waving like, you know, philosophers typically do, but it's a concrete theory. It makes concrete statements about which systems are and aren't conscious, and and how to go about measuring that. However, he says, also makes the statement that some of its implications are absurd and therefore must be wrong. So, for instance, IT says that in principle, if you have a two-dimensional grid of complex enough, very simple machines like cellular automata that maybe in computer that many computer scientists are familiar with, and you mesh them together in large sheets, they may have high levels of consciousness by the theory, yet they don't do anything. They're just sheets of of these cellular automatas linked together in like carpet like arrangements.
right,
uh, it is true. He's correct that our intuition quails before this. Our intuition says, well, we know conscious creatures, they go about, they run, they fight, they love, they hate, you know, because that's what you and I do, that's what dogs do, and cats and all the other animals that we're familiar with. And so I agree, it's extremely unlikely that a grid of these very simple elements would be conscious or have, let alone large degrees of consciousness. However, it's very different if you build it. If you build it artificially or you grow it in a vat. Like, for instance, you take what people do now, they build cerebral organoids. So what you do, you take cells, let's say from under your arm, away from the damaging rays of ultraviolet. You put them in a dish, these cells, they have your DNA. I add some transcription factors to it. So I differentiate them and turn them into pluripotent stem cells. And then I add some more transcription factor to it and let them grow for 9 or 10 months, roughly like a human baby. And then I get these cerebral organoids. So this is now in a dish where maybe have 1,000,000 neurons. And more recently, experiments have shown that these neurons can begin to signal, they have electrical signals. You can even measure a very primitive EEG that begins to resemble a primitive early EEG, let's say, of a preterm infant. And so it may well be that as our ability to grow these mini brains in a dish, if you want, that it grows, we actually have an experimental viable system whereby these networks of neurons actually may, for example, feel like something like the feeling of space. If you think about where does our feeling of space come from? If you stare at an empty blank wall, just an empty wall, nothing on it, nothing, no signs, no letter, nothing. You already have a feeling of space. You have the feeling of close by and far away. You can instantaneously tell me whether something is to the left, to the right, up, down. The neighborhood relationships, right? There's distance relationships. All of that is what makes seeing, what makes it very different from hearing or smelling. And so that is a form of consciousness. Now, typically we take it for granted. We never think about that. We think consciousness is higher consciousness. We think, well, consciousness, that must be about knowing that I'm a man and knowing I'm going to die one day and, you know, solving differential equations and all of that. And that is true for highly educated, you know, a subset of people. Most of the time, consciousness is just seeing, smelling, hearing, feeling weird body aches, feeling full, feeling bloated. Those are all different conscious feeling. So yes, it is a challenge, as Scott Aronson points out, some of the predictions of IIT. Of course, they have to be verified. How do we know that the sheet of neuron is conscious? It's a very good question. So for that, we need a theory, we need a measure of consciousness. We need practical tools that tell us this piece of brain, or for example, that patient, the patient is paralyzed, the patient may be anesthetized, or the patient may be in following a car accident, may be unable to respond. The theory has sort of developed tools that tell us, is this brain of this patient who's so severely damaged that he or she is unable to respond, can I still measure whether there's consciousness there? And so far, at least in patients, this has been possible. Yeah, so like any interesting, powerful scientific theory, think about the theory of evolution or the theory of black holes, the theory can make predictions, and these predictions can be terrible counterintuitive, but to the extent that these predictions can be verified, if they can indeed be verified, provide powerful support for the theory. This is the work that has to go on now and over the next years and decades, trying to take some of these predictions and test them actually in people or in other conscious systems.
Okay, so what I'm hearing is that yes, you're conceding that like a solar panel, or a lattice of just XOR gates would have some measure of consciousness, and possibly a very large measure of consciousness by the current way you would measure phi, but that because it's artificial, it's less, it's not appropriate to measure
No, no, I didn't. I meant that. I just, what I meant, it would never have evolved. Right. So let's look at what is the general relationship, because this is underlying the intuition that Scott has, between intelligence and consciousness. All right. So intelligence is the ability to quickly take in information, particularly new information, over a variety of timescales, and act accordingly in the short term, in the medium, and in the long term. Okay, that's sort of a very broad definition of intelligence.
Sure.
And then consciousness, as I just defined it, is sort of the ability to feel. Now, people have this intuition that, well, consciousness and intelligence are clearly almost the same or closely related. But then if you think about it, they're actually not at all related. I mean, they may be practically related in people or in animals, but at least conceptually, they're not at all related. Intelligence is the ability to process information and adapt to the environment over varieties of scales, of temporal scales, okay? That says nothing about feeling. Consciousness is about feeling, that for certain things, when I look or see or smell or decide or lift my left hand, I have particular feelings. I feel, I see something, or I hear something, or when I lift my right hand up, I have this feeling that I just wanted to make a point, and then lo and behold, my right hand lifts up, okay? A priori, the feelings don't at all relate. Why do they conceptually have to relate to acting? Acting in the world. Now, it is true in evolved systems such as you and I, and presumably animals, certainly closely related animals like cats and dogs and monkeys, etc. It seems to be true that intelligence and consciousness is related, but conceptually they don't have to be. And many people now make this point. So, for example, if you read Yuval Harari, Homo sapiens, he makes this distinction between intelligence, possibly artificial intelligence, possibly even high superhuman artificial intelligence, that still doesn't say anything at all whether these systems are conscious or not. That's just a totally different matter. And so now conceptually you can have this plane. You can think you have this two-dimensional plane of systems that are intelligent, little intelligent, or high intelligent, and conscious, little conscious, a lot conscious. So let's say on the x-axis, on the horizontal axis, you plot how conscious they are, from not at all on the left to highly conscious. Let's say, like a Buddhist meditating monk, or like you and me, okay? And then on the y-axis, on the vertical axis, you plot intelligence from basically no intelligence, like the intelligence of a toaster, to intelligence of a Madame Curie or Albert Einstein, okay? Now, if I look at humans and I look at biological evolved creatures, they live somewhere along the diagonal. In other words, if you have a small brain like a bee, it has some intelligence, right? They've been around for 80 million years. They are quite adaptive, but clearly, you know, a human can outthink them. So they're clearly smarter. And at least based on behavioral research and integrated information theory, I would say in the complexity of their brain that a bee is much less conscious than you and I. So we can plot them. But essentially, as the complexity of your brain increases, your intelligence increases, and your consciousness increases. But now if I think about engineered systems, if I think about systems that did not evolve by natural selection, but that somebody built, you know, like an engineer built, either a bioengineer like brain organoids, or an electrical engineer, computer engineer, okay? Then I can imagine populating different aspects of this consciousness intelligence plane, this what I call the IC plane, intelligence consciousness plane. For instance, I could imagine a super intelligent computer, like what DeepMind does, in like AlphaGo Zero, that is vastly better at playing any possible strategy game as they now are than any human, right? So Go, chess, poker, well, let's just stick with strategy games, but even all other games, they just vastly outcompete us. They're very intelligent, but there's no argument. I mean, nobody's ever argued that these feel like anything. They're just clever algorithms, okay? So in principle, at least, I can imagine even in a HAL, like in 2001, or some, you know, evil supercomputer that's more intelligent than any of us that might pose a threat to humanity itself, but it doesn't feel like anything. It just mindlessly executes whatever it's been told to execute, okay? But then so that's on one axis, high intelligence, but no consciousness. And on the other, orthogonal to that, I can imagine systems that have very little intelligence, but are high conscious, like this grid we're talking about, like this brain organoid. It doesn't have input. Right now, these brain organoids that bioengineers build have no visual input or tactile input, auditory input, and they have no output, at least so far. They have no motor neurons, anything like that. So they're just brains in a dish. So in principle, at least, it's possible that they have some measure of consciousness, but have no intelligence. Same thing, to get back to Scott Aronson, it may well be true that yes, you could build these sort of XOR gates, and you build vast two-dimensional grids of them. They just sit there, they quietly do their thing, but they don't have any intelligence because they don't know anything about the real world, and they aren't hooked up to sensors, and they are not hooked up to effectors, but they may well feel like something. And they may well feel that whether it's artificial or it's evolved.
Okay, yeah, there a couple things were going through my head while you were saying that. One is the famous Alan Turing paper where he talks about basically it's the one where he describes the Turing test, and like one of the first sentences in it is asking whether or not machines can think is too meaningless a question, so we're gonna like put that aside. In other words, like it's like asking if a submarine can swim. Like if you want to call that swimming, you can go ahead. Is that kind of your position?
Well, yes. So it's a very good question. So he sidestepped the question of consciousness. He operationalizes it by this. He says, I do not address the question of consciousness, but here I have a pragmatic test. And that's really, the Turing test is about intelligence. So what he talks about in this paper, I think it was called Computing Machinery and Intelligence, is intelligence. And once a machine passes this sort of a universal Turing test, and not just games it like a chatbot, but actually pass it, then I think we can say, well, this machine seems to be as intelligent as a human. It can converse about any topic, and you cannot tell with certainty whether it's a machine or a person. Then at least we have to say, well, whatever else it is, it's as intelligent as a human. That is very different from the question, does it feel like anything? And Turing explicitly does not go there. He doesn't say this means that this machine is now conscious. He just says that relates to, can it be said to think? And in some pragmatic way, yes, it can be.
Sorry, go ahead.
So the Turing test talks about intelligence, not about consciousness.
Okay. Could you, if you could engineer intelligence, could you not engineer consciousness? I mean, like the brain is just a certain organization of matter. I mean, couldn't that be replicated at some point on silicon, or, pick your computer chip?
In principle, yes. As you point out, there's nothing extra natural about the human brain. So in principle, if you could replicate it in the right hardware, you would get all of its properties, including consciousness associated with it, yes. However, if you look at digital machines, you look at CPUs, the von Neumann architecture, where typically you have one transistor gate that's connected to a small number of other transistor gates, where they have very little overlap in their input and their output. This architecture, at least according to IoT, generates basically no consciousness. And so the IoT makes a strong claim here. IoT says if we take current computer architectures, let's say we fast forward, we're now 100 years later and we have a super duper, maybe quantum computer, okay? And it perfectly well simulates you or I. In fact, maybe somebody, a neuroscientist, 100 years from now at USC builds this perfect computer model of the human. It models all neurons and it has cortex and cerebellum, basal ganglia and whatnot, okay? Everything is in there. And of course, it's gonna wake up, quote, and say, I'm conscious. It's all a deep fake. It's as much a deep fake as a computer program that actually exists today already that generates, that models or simulates the gravitational power of the central mass at the center of our galaxy, right? As you probably know, there is this huge mass. It weighs roughly 1 million solar masses at the center of our galaxy. In fact, probably at the center of most galaxies. And per Einstein field equation, it's so massive that it twists space-time around it. Okay, so nothing can escape, including light. But suddenly, I don't have to be concerned if you're running this computer simulation of this super duper black hole. I don't have to be concerned that you're going to be sucked into this computer simulation. But why not? It simulates. It's as good as the physics as we understand it today. It simulates what happens out there at the center, at the core of our galaxy. So why doesn't it have the power? Well, because it doesn't have the causal power of gravity to bend space-time. That you cannot simulate. You have to actually build into the physics of your system. You have to actually have a million solar masses mass in your computer to be able to have the causal power to bend space-time around you. Same thing according to IoT with consciousness. Consciousness ultimately is intrinsic causal power, the ability of any one system to be influenced by its past and to determine its own future. Leibniz, the philosopher and mathematician Leibniz, has this beautiful phrase, pregnant with its own future. Our brains in that sense are pregnant with our own future. My brain has a power to have a certain prediction what it'll say in a minute, in 5 minutes, in 10 minutes, or in an hour from now. And that you cannot simulate, you have to build into the physics. So once again, the answer to your question is yes, if I build with the proper neuromorphic hardware, if I built the brain or rebuilt it in a different hardware, in principle, I could recreate human consciousness, but not on digital conventional computers. So there will never be a system in the cloud using current computer architecture that will be conscious. Although there may be lots of fake consciousness, lots of fake bots that claim that they feel like something.
This is a somewhat different topic, but how much have you paid attention to the research done around psychedelics and their effect on consciousness, including a loss of sense of self, a change in perception of time, and sort of mostly the loss of sense of self and feeling like you're no longer an individual person. Do you?
So are you referring specifically to 5-methoxy dimethyltryptamine?
Yes, that would absolutely be one of the more prominent examples.
Yeah, so it is true that under certain drugs, in particular 5-MeO DMT, also, or maybe sometimes under DMT, you can also get these states under prolonged forms of meditation. You can get them in an isolation tank. Some people report them as so-called near-death experiences, where you can experience loss of time, complete cessation of flow of time, and complete loss of self, complete loss of any peripheral input. So you may not see anymore, you may not hear anymore, you don't even know, there is no more you. There's what Buddhists refer to only as a non-dual self present. You're intensely conscious, but your consciousness is sort of very, maybe just a point of light, of unbearable light, or feeling of ecstasy, or feeling of dread, or possible feeling of both ecstasy and dread, without there being any notion of you. So the you, the Duncan, your memories, your traits, your desires, your fears are no more there. Yeah, so what that tells me is that that the consciousness of self, that's there all the time, is just one aspect of consciousness. In fact, it is an aspect of consciousness that often hinders us, that makes us unhappy, because we're constantly thinking about ourselves. We're constantly reminded by this nagging voice in our head that, we still haven't done the dishes, and there's this issue and that issue, and we're just inadequate. And that's why so many people, try to lose themselves in either mindless, video gaming, or mindless watching movies, or they go out and climb, rock climb. I used to do this for a long time, where you find ecstasy precisely in losing yourself, precisely because when you're climbing on the sharp end of a rope, you're on a big wall, everything else is gone. That sense, that inner critic is totally shut up and mute, because you're hyper conscious of everything else. And I think you can experience similar states with 5-MeO or with some of these other techniques. And typically they're experienced as really people come back very changed from these experiences, which paradoxically really leads me to believe that the sense of self isn't quite what it's made up to be. It can really be a big detriment. And of course, that's what Buddhists often teach us.
Could you elaborate on that when you say the sense of self is not all it's made out to be, in terms of the inner critic, or?
Many people, particular intellectuals who tend to write books, and philosophers, overemphasize self-consciousness at the expense of just consciousness in general. When you're out there, when you're really fully engaged with the world, when you're making love with your loved one, the act of love making, you forget everything else. When you're really absorbed by a book or by a movie, you forget everything else. What does it mean? You forget that you're you. You're not you anymore. You're now out in the world. You're engaged. You're inside the body of your lover, or you're fully engaged with the movie, right? Or you're fully climbing, or you're on a bike, or you're fully playing a game. You're completely immersed in the game. And all that detritus that constantly is there all the time, the worries, and right now it's COVID, and then it's the demonstration and systemic racism and all of that, that's all gone. You're fully absorbed. And that seems to give rise to much more contentment than this endless spending time in our head, regurgitating, endlessly recycling what I could have said, what I should have said, and what did she say, and this and that and the other. And of course, this is one of the teaching of the way, of Buddha, that the self, focusing on the self, we have to overcome that. One of the adages of Western philosophy is know thyself. And so part of that knowing that thyself is to realize the self, to a certain extent, is an illusion. It's a very powerful illusion, but it is an aspect of consciousness that we emphasize at our own cost. And that there are techniques like meditation, or like certain sports, or sometimes like drugs, but they have other dangers, of course, that can lead to a loss of self, which usually people perceive as being of great benefit to them.
I wanted to ask you before I let you go, because I've taken up enough of your time, but there's something that Chomsky said, who I had on this podcast, and he was saying that a lot of people are speculating about consciousness, and thinking that the really hard problem is consciousness. But he said that he believes that unconscious experience is probably a much harder, deeper problem. Like the words that are coming to us in this conversation right now, we're not really thinking or aware of the process of their formation. They sort of just happen. Um, do you think that Chomsky's right about that, or do you see that as being compatible with everything we've said today, or what are your thoughts on that?
It may well be true that in terms of sheer information processing, everything I do unconsciously, like you said, I somehow have instantiated in my brain the languages, English language rules. If you ask me about preposition and why this declination or that, I have no idea. I just know from having lived in this country for 35 years, I know I can tell you what's a good sentence, what's a bad sentence, okay? But I have no idea how I do it. My brain does it. So in a sense, that's a very complex operation that my brain performs, and it's done, as you point out, entirely unconscious, and Chomsky is correct. And it may well be that the information processing that's associated with consciousness may well not be as complex as that associated with unconscious. But then I point out consciousness is not directly related. It's not a computation. It's not a clever trick away. It's not a clever hack away. In the view of consciousness that IIT describes, consciousness has something to do ultimately with the ultimate reality of the universe, which is causal power. Ultimately, there's nothing but causal power. It's external, as Aristotle said already. There's external causal power, the ability, let's say, of gravity to affect mass, or electricity to affect charges, and there's internal power. That's what consciousness is. And so in terms of complexity, it may be less complex than unconscious, but it's very different from everything else in science. That's why it's still a problem, how to fit in consciousness into everything else in physics or biology and chemistry. But it's simply of a different kind. It's not a computation under this view. Consciousness and computation are two very different things.
Well, I think on that note, that's a good note to end it on. Christof,
Right.
Thank you very much for taking the time to do this. I hope you do well in the coming days, weeks, months, years.
Thank you. Thank you. You asked some good questions. Yes. Thanks a lot, Duncan.
Awesome.
All right. So you got what you wanted?
Absolutely. Yeah.